Hello, Algebra, and welcome to Lesson 2-4 on parallel and perpendicular lines. This is pretty much an extension of your linear equations topic here. So this is very much geometry related, and you will talk about this, a full section in geometry. So let's go ahead and revisit what parallel and perpendicular lines are, right? So parallel lines, two lines that never intersect. So again, if you have a line here and a line here, right? Sorry, that one's not as long as the other. These are parallel. Now, perpendicular, on the other hand, they do intersect, and they intersect in a special way. Perpendicular lines intersect to form right angles, like this. So typically, we put a little right angle box there to show perpendicular. So this is perpendicular. So do not confuse intersect with the word perpendicular. Perpendicular lines intersect at right angles. So again, we're going to use our linear equations from the first three sections to help us in this section. All right, so example 1, it says, what is the equation of the line in slope-intercept form that passes through the point 8, 9 and is parallel to the graph of y equals 3/4 x minus 2? So again, we want to finish this problem in slope-intercept form, and we have a parallel question, okay? Well, again, as we just talked about, parallel lines are lines in the same plane that never intersect. And a very, very, very key thing about parallel lines is that they're going to have the same slope. They're angled the same way, so they're going to have the same slope. So first thing we're going to do is we're going to use point-slope form to come up with this equation, and then we're going to transform it into slope-intercept form. So let's recall that point-slope form, y minus y1 equals m parentheses x minus x1. All right. Now, they give us a point, right? It's called point-slope form because we need a point. The point they give us is 8, 9. That's going to be our x1, y1. Now, the slope we need is going to come from the line they give us. This is slope-intercept form. The 3/4, this is the mx part, right? M is the slope. So our slope here is 3/4. Now, because our line is parallel to this line, it's going to have the same slope. So we're going to use 3/4 as our slope. So now we're just going to plug in our numbers. So y minus, all right, y1 is 9, equals m is 3/4 parentheses x minus, and x1 is 8. Okay, so now what we're going to do is we're going to put this into slope-intercept form. Y equals mx plus b. Again, if you need a refresher, slope-intercept form, y equals mx plus b. So the first thing I'll do is I will go ahead and distribute the 3/4. So this would be y minus 9 equals 3/4 times x is 3/4 x. And then we'll do 3/4 times negative 8. So in Desmos, I would just type in 3/4 times negative 8. And it'll give you the answer of negative 6, minus 6. And now to get y all by itself, we're simply going to add 9 to both sides. I'm going to draw my line. I'm going to bring it right over here. So y comes down, the 9's cancel, equals 3/4 x comes down. And then again, just Desmos, negative 6 plus 9. That's a positive 3. And this would be the equation going through, the equation of the line, going through the point 8, 9 that is parallel to the line y equals 3/4 x minus 2. That's our goal today, writing some lines. Okay, so that was the parallel line example. Let's look at perpendicular. Now, before we get there, we're going to talk about understanding two perpendicular lines. So it says, A, how can you create two perpendicular lines? So again, perpendicular lines are lines that intersect to form right angles. So what we've done here is we've drawn two lines. One's blue, one's red. So I want you to think in terms of right triangles. I'm going to drop a right triangle right here using the red. And then I'll change colors. I'm sorry, I'll put the right angle right there. And then let's draw a right triangle over here using blue. Okay, so each triangle has a right angle. Now, the other two angles in each triangle we're going to label as A and B. So I'm going to call this angle A right there, this angle B right there. Now, I'm going to call this angle right here. This angle is also going to be A. Here is the reason. These two triangles are exactly the same. If you look, this side is 4, and this side is 3. Over here, this side is 3, and this side is 4. They both have a right angle. They're going to be exactly the same. So this angle up here, A, is also this angle down here, A. And vice versa. This angle here, B, is also this angle here, B. So again, this might be a little bit more geometry-esque, but we're going to do our best here. And then we're going to label this angle right here as N. And now we should know that the x-axis here, this is an example of a straight line. These three angles, B, N, and A, they make that straight line. A straight line is also a straight angle. That's 180 degrees. So we should know that if we add A plus B plus N, that should be 180 degrees. And again, it's because it's a straight angle or a straight line. Straight angle. Well, now in each right triangle, so for instance in triangle, this red one, right, A, B, and 90 add up to 180. That's called the triangle angle sum idea. I think you know that. So if 90 is already there, A and B must add up to 90. A plus B must be 90. And again, that's because you have a right triangle. In a right triangle, these two angles have to add up to 90 because 90 and 90 is 180. Well, I see AB here, and I see AB here. Well, we can take this 90 and replace it in for A plus B. And this is going to say 90 plus N equals 180. Let's subtract 90 from each side. And N is going to be 90. This angle right here is a 90-degree angle. This angle right here is a 90-degree angle, which means that these two lines are perpendicular. So we just showed how to make two perpendicular lines. Here's an example. Okay. Now, if that was too much for you, that's fine. Know that perpendicular lines form right angles. So now we're going to use this to talk about the slopes of perpendicular lines in the next slide. Okay, here we go. So it says, how do the slopes of perpendicular lines compare? Slopes. Let's take a look here. Notice for these triangles, they have already labeled the sides for us. Okay. So what we're going to do here is we're going to look at the slope of line L. L is the blue line. Recall slope is y2 minus y1 over x2 minus x1. It's also rise over run. So we're going to use the point at the origin, 0, 0, and we're going to use this point right here. That point is at negative 3, 4. And we're going to do the slope between those 2 points. So y2, let's let 4 be y2 minus y1, which is the y of 0, 0. And then let's do the x, negative 3, minus the x of 0, 0, which is 0. And that's going to be 4 over negative 3, which is just negative 4/3. And now let's do the same thing for line P. Again, we'll use 0, 0, but now we'll use this point right there. That's the point 4, 3. So to find the slope of P, we're going to take y2, which is 3, minus y1, which is 0, over x2, which is 4, minus x1, which is 0. And that's 3/4. And as you can see, these two lines, look, these two slopes look very similar. One's negative, one's positive, one's 4/3, one's 3/4. Negative 4/3 and positive 3/4 are example of what we call our opposite reciprocals. This is going to be true for the slopes of any perpendicular lines. So a general rule, if one slope is A over B, the other one, so A over B and negative B over A. There's your general reciprocal form. Now, some books will tell you that opposite reciprocals, or slopes of perpendicular lines, multiply or have a product of negative 1. And they're not wrong. If you take negative 4/3 and multiply it by 3/4, this is similar to what you did in topic 1 when getting rid of a fraction multiplied with a variable, except the signs would have matched. But here, the 4's cancel, the 3 cancels. When numbers cancel in multiplication terms, that's 1. So this would be negative 1, because a negative times a positive is a negative. All right, so that's a check that some books will use. All right, so we're going to stop there, and we're going to take a look at a problem involving perpendicular lines. All right, video 2 is coming up next.